If you've looked at an AI startup recently, you've seen the term RAG. It is the most heavily used buzzword in tech today. This technology has become the industry's primary answer to the problem of AI reliability. RAG works by handing the software a highly organized reference library, instead of trying to teach it new skills from scratch. To fix the biggest flaws in artificial intelligence, we don't have to rewrite the software's brain. We just have to change what it reads before it speaks. Asking a standard AI a question is like forcing a student to take a closed-book exam. The software sits down to answer your prompt using only the facts it memorized during its initial training, which could have been months or even years ago. When you ask for a fact it doesn't quite remember, it doesn't leave the page blank. It guesses, it bluffs, it fabricates a plausible answer. In the industry, we call this a hallucination. You might think the solution is to just teach it the new facts. But putting an AI through that permanent training process costs millions of dollars and takes weeks of massive computing power. You cannot afford to retrain it every time a single company policy changes. Because of this, a standard closed-book AI is practically unusable for serious business tasks. You can never definitively trust a system forced to rely on a frozen memory. This diagram shows how RAG turns that closed-book exam into an open-book test, with a lightning-fast librarian helping out. Notice how your question enters from the left and immediately splits into two separate paths. Following the bottom path, we see the retrieval phase. A specialized search engine intercepts your question and scans through a digital reference library of PDFs and internal wikis. It quickly extracts just the single paragraph most relevant to your question. Now follow the path looping back up. That extracted paragraph merges with your original question, and both are handed over to the AI brain. This is the generation phase. We give the AI a strict, rigid instruction. Read this provided text and answer the user's question using only these exact words. No guessing allowed. Because the AI is looking directly at the paragraph we supplied, it can easily cite its sources. It can point to the exact page of the document it used to get the answer. By strictly controlling the text the model sees, RAG turns a creative guesser into a grounded, accountable researcher. When builders first encounter the frozen memory problem, their initial instinct is often to try and use permanent training to bake their private data into the AI's weights. But permanent training is like carving information into a monolithic stone block. It's incredibly slow, expensive, and instantly outdated the moment a policy changes. RAG bypasses this entirely. If a policy updates, you just swap out the reference document in your library. The knowledge update is instant and costs almost nothing. There is a dangerous misconception, though, that setting up a RAG system completely cures AI hallucinations. That isn't true. The system is highly vulnerable to the garbage in, garbage out rule. If your search engine pulls up the wrong document or an outdated policy, the AI will confidently read it and give you a factually incorrect answer. RAG shifts responsibility for accuracy away from the AI's internal brain, placing the burden entirely on how well you organize and search your library. Recently, tech giants have released models that can ingest hundreds of thousands of words, or even whole books in a single prompt. This raises a question. Why bother building a retrieval system if you can just stuff your entire company library into the prompt every time you ask a question? This diagram shows exactly why the brute force method struggles. On the left, shoving a massive library into a prompt creates severe lag and astronomical costs. Even worse, the AI often suffers from lost-in-the-middle syndrome, where it simply ignores data buried deep inside long texts. On the right, RAG delivers a tiny, surgical data packet that slides effortlessly through processing. Just because an AI can read 10,000 pages at once doesn't make it the efficient, scalable, or financially viable way to get a simple answer. So here is the definitive rule. You should use permanent training only when you need to change the AI's behavior, its tone of voice, or a specific formatting style it outputs. You should use RAG when you need the AI to access private data, cite verifiable sources, and stay continuously up to date. In fact, the most robust enterprise systems running today actually combine both techniques to get the best results. If you want a grounded, accurate AI, stop wasting time trying to rewire its brain. Just focus on slotting in a new, high-quality text for it to read.